My name is Nurjuzulaika binti Sarasari. My metric number is CF210145. In civil engineering, the integration of acoustic and lighting is crucial as they significantly influence the design and functionality of built environment. Acoustic, the science of sound, focuses on sound insulation, reverberation control, and noise reduction to enhance pitch intelligibility and create comfortable spaces. Lighting, on the other hand, enhance the visual appeal, functionality, and safety of spaces, positively affecting mood and productivity. The innovative approach of acoustic lighting addresses both acoustic and visual needs simultaneously, enabling the creation of multifunctional spaces that do not compromise on comfort and efficiency. This balance is essential for various contexts, from residential homes to large public venues, ensuring a holistic and effective design. In classroom design, reverberation time and illuminance are crucial for speech intelligibility and the overall learning environment. The time for sound to decay by 60 decibels should ideally be between 0.4 to 0.6 seconds to ensure clear communication. Exceeding this range can cause prolonged reverberation, masking speech and causing confusion. Optimal illuminance level, typically 300 to 500 lux, are essential for visual comfort and effective learning. Inadequate lighting can lead to visual discomfort, reduced concentration, and hinder academic performance. Guideline for acoustics. Sound absorption. Use sound absorption material like acoustic panel and carpet. Sound diffusion. Incorporate diffusive element to scatter sound wave. Ceiling design. Install a suspended acoustic ceiling with sound absorbing tiles. Wall treatment. Treat walls to minimize reflection. Seating arrangement. Arrange seating in a tiered configuration. HVAC system. Ensure HVAC systems operate quietly. Sound reinforcement system. Use high quality microphone and speakers. Noise isolation. Isolate the hall from external noise. And the last one is regular maintenance. Regularly maintain all acoustic treatment and system. Guideline for lighting. Natural light utilization. Maximize natural light with large windows and skylights. Use light shelves and reflective surfaces. Layered lighting. Implement ambient, task, and accent lighting. Dimmable lighting. Use dimmable fixture for adjustable light level. Uniform illumination. Ensure even light distribution with indirect lighting technique. Color temperature. Choose 400K to 500K. Cool white lighting. Glare control. Minimize glare with diffusers, louvers, or buffers. Energy efficiency. Use energy efficiency LED fixtures and lighting control. Emergency lighting. Equipped with adequate emergency lighting. And the last one is maintenance. Regularly inspect and maintain lighting texture.
Assalamualaikum. So for net measuring reverberation time, so first setup, place sound source at 1.5 meter height in the room center. Adjust sound pressure level SPL using a tripod. For the procedure, turn on SPL, connect to transmitter and adjust parameters. Calibrate using a microphone and press start. Wait for sound stabilization and absorb result. Repeat measurement at multiple locations, keeping SPL 1 meter from wall. So for next, measuring lighting, setup, first create a 1 meter multiplied 1 meter grid based on room dimension, measure distance with laser meter and record grid detail. And for the procedure, using a lux meter to assess lighting on the grid, adjust lux meter height, center height for teaching, table height for the student. So lastly, analyze data, create contour and recommend lighting improvement. So next for the layout, this Dewan Kuliah 1 at Perpustakaan Tengku Tun Aminah UTHM. This drawing using by SketchUp. So the condition is the Dewan have 250 chair and have a 40 row, 38 ceiling lighting and 8 acoustic panel.
Hi, my name is Nur Arisha Faria binti Kamal Zaman. My metric number is TF210037. Now, I will share the findings from our acoustic analysis in Dewan Kuliah Point. We focus on two main aspects, which are reverberation time and background noise level. Firstly, about reverberation time, measurements were taken at 18 different positions in the room. At low frequencies like 63 Hz, the reverberation time was quite high up to 2.02 seconds, but as the frequency increased, it dropped significantly, going down to just 0.45 seconds at 8 kHz. On average, the reverberation time for speech was 0.74 seconds, and this shows that the room has decent acoustic control but struggles a bit at lower frequencies, which could slightly impact speech clarity. Next, for background noise, the noise levels were higher at low frequencies with an average of 42.66 dB at 63 Hz. However, they dropped as frequency increased and reaching only 10.34 dB at 8 kHz. By using an online tool, we calculated a noise rating of 23 dB, which is far below the recommended levels for lecture halls. So this means that the room has excellent noise control as it has effective insulation and soundproofing. Therefore, Dewan Kuliah 1 is a quiet space with a good acoustic qualities that making it very suitable for lectures and discussion. That's all from me. Thank you.
Hi, my name is Nur Rosnina binti Nisa. My matrix number DF210070, and I will present the analysis on the illuminance of the room. Good lighting is important in lecture halls to make learning comfortable and reduce eye strain. This project looks at the lighting levels in a TK1 at lecture hall at the University Tun Hussein On Malaysia Library. We measure the light distribution to find areas that are too dark or bright and to check how evenly the light is spread. Light measurements were taken every 2 meters, showing uneven lighting. The center of the hall is very bright with 550 to 60 lux, while the edges are too dim, which is below 200 lux. This uneven lighting causes glare in bright areas and poor visibility in darker spots, making it harder for students to concentrate. According to the MS 1525 2014, the recommended illuminance for lecture hall is 300 to 500 lux, but the hall's average is 269 lux, far too high and uncomfortable for the student. The uniformity ratio is only 0.279, much lower than the recommended, which is 0.7, showing uneven light distribution. Although the lighting meets the standard for the color accuracy, which is CIR of 80, the brightness and uneven lighting need fixing. Adjusting the placement of lights or adding diffusers could have improved the situation.
Hi, Assalamualaikum. My name is Mohammed Abdi Mahmoud, and I am from Group 7. I would like to present the proposed justification for our acoustic improvement. We have in our acoustic several issues, which include the high sound pressure level, and we have a lack of sound installation, which has no sound index. We have also excessive reverberation. And so in order to improve the proposed acoustic, we use an acoustic panels, bass drop, and also the sound installation. For the acoustic panels, we reduce the T as 30 and from 1.5 to 0.6 seconds. And also we add a 12.07 image square absorption. And also we add a bass drop to trap a sound. And the third one is the sound installation. We used to install the sound installation in the wall and ceiling. For our proposed lighting, we have also several issues, which include the insignificant illumination. And also we have poor lighting distribution, which can cause a glare and shadow. And also we have a lack of lighting task, which can make it difficult for reading and writing. So in order to improve the lighting for our room, we used to make a general 5 LED illumination around 500 lux. Also, we use a distribution for a linear and almost uniformly less than 0.7. The third improvement is to use a task adjustable lamp around 300 to 500 lux, which is good for focusing on work.
The acoustic assessment of Bilik Kuliah 1 located in the library shows an average reverberation time of 0.74 seconds and average background noise level of 48 dBA. While the reverberation time is slightly above the recommended standard for optimal speech intelligibility, it remains manageable. However, the background noise level significantly exceeds the standard of 35 dBA, which is essential for clear communication. To improve the acoustic environment, additional sound absorbent material and noise control measures are recommended. The lighting assessment reveals an average illuminance level of 2069 lux, far exceeding the Department of Occupational Safety and Health (DOSH) guidelines of 300 to 500 lux for educational spaces. This high illuminance level can cause visual discomfort and glare, especially since there are no windows to balance the artificial lighting. Adjusting the lighting design to achieve a balanced and appropriate illuminance level is necessary to ensure visual comfort and enhance the effectiveness of the space for education activity.